Hello, beautiful people, and welcome to 6.5 and 6.6. Today we're going to be graphing linear inequalities and systems of linear inequalities. So good idea. If you haven't done so just yet, go ahead and get a ruler or a straight edge or what have you, something that you can draw really nice straight lines. If you have like a darker pen or a really sharp pencil, then I think we'll be in pretty good shape as well. So our SWABAT is just that. We're going to graph linear inequalities and systems of linear inequalities in two variables. Vocabulary. What is a linear inequality? I know you're wondering. A linear inequality in two variables can be formed by replacing the equal sign in a linear equation with an inequality symbol. So we're going to be looking for less than, greater than, less than or equal to, or greater than or equal to instead. The solution of a linear inequality is any ordered pair that makes the inequality true. Now, let's talk about some steps. Number one, we're going to write each equation in slope-intercept form, y equals mx plus b, remembering that my m is my slope, and the numerator will tell me to move either up and down, and the denominator will tell me to move either left or right. And the b, the y-intercept, is my starting point. It's where I will begin. Then we're going to graph the line that we get from there, and instead though it could either be a dashed line like that, or it could be a solid line, which is what you're used to. Once we draw it, we're going to shade. We will shade below, kind of makes sense, for less than or equal to, and we'll shade above the line if it's greater than or equal to. And when in doubt though, we can always use a test point to confirm what we've done. Okay, so this is where I'm going to place my graph for part A. And I'm going to go through the steps here. So graph the inequality in my directions. Step 1, write the equation in slope-intercept form. So I want to get the y by itself. I'm going to subtract 3x. And I get negative y is greater than or equal to, that's what that's supposed to be, greater than or equal to negative 3x plus 2. Then I will divide by negative 1. Funny things happens when you divide by a negative number. We flip the arrow. So now it's going to be pointing to the left. This is a positive 3x minus 2. So my slope is 3, but as a fraction, 3 over 1. My y-intercept will be 0, negative 2. Okay, we said it before. We'll say it again. B is where I begin. So I'm going to start at negative 2. And then my slope, because it's 3 over 1, positive and positive, I'm going to go up 1, 2, 3, and right 1. Up 1, 2, 3, and right 1. If I wanted some points on the other side, I can go down 1, 2, 3, and left 1. Now, the next thing is we ask ourselves, this was, although it was weird here, it is greater than or equal to. This one is less than or equal to. If it has a solid line underneath it there, guys, then when you graph it, you should have a solid line as well. Now this line that you have just drawn, hopefully, and hopefully it's straight because you use a straight edge, either a ruler or your student ID. We also accept Visa and MasterCard. Any card that has a straight edge will be great. It's solid. This is known as our boundary line. You got to be very, 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 very clear and bold about what your boundaries are. It's a life lesson. Tell St. Julie I told you that. Now we need to shade. So let's read this, please. This says less than or equal to. Less than. So if you're thinking about a line, is less than above it or below it? Less than is below it, underneath it. So in my mind, I'm thinking that less than is going to be this area right here. Less than. I'm not going to shade it though. I'm going to get a confirmation point. A confirmation point means that I can pick any point on the side that I think it is, which for me, I think it's this side. I'm going to point to it with this pen. So let's pick an easy point. Let's say any point that's not on your line will do. So here's the point 2, 0. I think that this point is where I need to shade. I'm just going to confirm it. This is an x and this is a y. I'm going to go back to the original equation. And instead of x, I'm going to put 2. And instead of y, I'm going to put 0. And I'm going to check to see if this is a true statement or not. This is 6 minus 0. This is 6. Is 6 greater than or equal to 2? Yeah, every day, all day. That means that this side and everything on it is also true. So that's where we will shade. Some people don't like that, and they just prefer to use all those beautiful highlighters that they have, which is beautiful to me as well. So if you prefer to use a highlighter, be my guest and highlight that area instead. People get creative. I'm good. All right, let's try another one just like the other one. 3y is less than -9. First thing I need to do, let's get this y by itself and have y is less than, I didn't divide by a negative number, so I'm not flipping the arrow, less than -3. I can either remember that this is going to be a horizontal line, or I can go back to my definitions that I have up here. I know that my slope, m, is 0 because there's not an x term, and the y-intercept is 0, -3. So as a fraction, it would be 0 over 1. So if I begin at 0, -1, 2, 3, then I'm going to go up 0, right 1, up 0, right 1, up 0, right 1. Now, this is my horizontal line, which is what we thought it was going to be. But is it solid or is it dashed? Correct. It is dashed because it doesn't have an equal to sign there. So I'm going to make my dashed line here. Now that's cool, but remember, I do want you to be super duper clear about your boundaries. So I'm going to go over it to make sure that everybody knows this is a boundary, this is a line. I don't want you to cross it. Boundaries, super duper important. All right, so next thing we need to do is think about our shading. And it says less than. So what is less than? Is it above or below? Less than, we know, is below the line. There you go. If I wasn't sure, like for this one, I was like, I think it's this part. But I wanted to make sure, so I chose the 0.20. You can pick any point under this line and just to confirm it to make sure that you're good. Or trust me. Side note. Can I give you a side note? I'm going to. What if it was x is greater than 2? So you have your xy axis. Let's say here's 2. We know it's vertical because it's an x. And then instead of thinking about, okay, well, what's that above or below? No one cares because x tells us with regards to left and right. So which numbers are greater than 2? The numbers to the left of it or the numbers to the right of it? Very good. The numbers to the right of it. So I would shade to the right for that one. This would be like my axis. Okay, so remember x will be a vertical line, and then for greater than, shade to the right. Left, less than, shade to the left. Okay, one more, my pretties, one more. I'm going to take these two equations separately. So first, 3x plus y is less than 1. I'm going to do what I just did and go ahead and get it in slope-intercept form by subtracting 3x to both sides. And I know that my slope is -3 as a fraction over 1. My y-intercept is 0, 1. Cool. So I'm going to go 0, 1. And then from here I'm going to go down 1, 2, 3 and write 1, down 1, 2, 3 and write 1. Now, my question is, solid or dashed, guys? What do you think? Solid or dashed? Did you say dashed? I sure hope you did, because if you did, you are correct. But not just any old dashed line. Just because it's dashed does not mean that it can't be clear. I want to be super duper clear about your boundaries. We all need them. Every good relationship has very clear boundaries. I'm done. Now, above or below. I believe that this is below this line. Not really positive though. So here's a point, -1, 0. This point right here, -1, 0. This is what I think I'm supposed to shade on this side. I'm just going to verify it by plugging in x and y. I can use this equation or this equation. It doesn't really matter. I'm going to go back to the original one though. So 3 times -1 plus 0 is less than 1. Truthfully, you can pick any point in here. I try to pick one that's on the axis just because it's usually easier because it has a 0 in it. So 3 times -1, -3 plus 0 is -3. Is -3 less than 1? Yes, it is. Check. I'm right. Now listen. Don't go crazy with the shading. In fact, I'm not even going to use my marker. I'm just going to use a pencil for now. We're going to go heavy in a minute, but not right now. Not yet. Okay, right now though, what we will do is this other one, and this is less than or equal to. Let's see how the less than and equal to sign, kind of whack. X minus y. Truth be told, it's because I couldn't figure out how to get this symbol in this document on my iPad, and then I forgot to switch it over when I got to a real computer. My bad. Less than or equal to 3. Minus x, negative y, less than or equal to negative x plus 3. Cannot have a negative here. I'm going to divide by negative 1, as we did in example A. And I have y is now greater than or equal to x minus 3. You like it? I love it. My slope is 1 over 1. And my b, my y-intercept, where I begin, is 0, negative 3. 0, negative 1, 2, 3. And then I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And then I'm going to say, always ask you the same question, solid or dashed? Solid or dashed? Well, there's a solid line underneath it, so I'm going to go for a solid line when I graph it. See what I did there? Now look at me. Look at me now. Super bold. Can you see my thing? Yes. Why? Because I am clear, at least in algebra, about my boundaries. Now this says what? Y is greater than this line. Greater than. So greater than above or below. Pretty clear to me that above is here. But if I wanted to make sure, here's an easy point to test 0, 0. So I'll go back to the original. 0 minus 0 less than or equal to 3. Is 0 less than or equal to 3? Yeah, it's just like the thing said. I'm always right. Just kidding. But yes, I am left-handed. So I will shade here. And this is kind of starting to look a little bit like a mess, right? However, let me highlight this. My solution, beautiful people, is my double shaded area. So the part where there's 2 shadings for me, and you should be as well, it's this part. Don't go past the boundaries though. And there you go. I should be able to see it from a distance. So if you hold your paper back from you, like at arm's length, you should still be able to see very, very clearly where you have double shaded and where your boundaries are. Well, that was fun. Thank you so much for joining me, and I hope that you have a delightfully blessed day. Bye, guys.